Hello, I J. Vijay Chandra welcomes you to WITS Connect. As part of Computer Architecture and Organization subject, today we are going to discuss regarding stacks, queues and subroutines, which are the major important concepts in computer architecture and organization as well as data structures and algorithms. So, first we are going to see regarding stacks. What is a stack? Stack is a basic data structure which can be implemented anywhere in the memory. It can be used to store variable which may be required afterwards in the program execution. In stack, first data input be the last get out of the stack, that is first in last out. Okay, let's discuss regarding stack. Stack is a basic data structure which is implemented in the memory. Since it is implemented in the memory in computer organization and architecture, we are discussing about it. Since stack is a basic data structure, we even discussed this regarding stack in the data structure concept. So this stack concept will be repeated in 2 or 3 subjects. One is computer architecture and algorithms, another is data structures, and another is regarding algorithms. So now we are going to discuss regarding what is a stack. Stack is a bunch of memory cells which are arranged. Oka book by oka book పెట్టడం. If it come up to a particular stage, then we will call it as a stack of books. After one book, we are keeping another book. After another book, we are keeping another book. We are keeping another book. That is called as a stack of books. In the same way, if we are keeping one memory on the another memory on the another memory, that is called as stack of memory. So here you can see here, this is the stack of memory. What it is? It is a stack of memory. What it is doing? This is A memory allocation, this is B memory allocation, this is C memory allocation. These 3 are the memory allocations where you are going to keep the one after the another stack. So whatever you are going to put into the memory allocation, this procedure where you are going to put, that procedure is called as push. What it is called? It is called as push. The memory, the data which we are going to insert into a stack is called as push. Whatever we insert into the stack, it is called as push. If we are taking out, if we are taking this out, it is called as pop. What it is called? It is called as pop. So the major terms or major activities done on the stack are push and pop. Push and pop are the both basic terms or basic activities which are done on the stack. So there are 2 possibilities to do. One is to push. Push means we are going to insert. How far you can insert? Until it completes the stack memory, until it overloaded, until it fills. Until you fill the stack memory, you can push it. How far you can pop? Until the stack memory is empty, you can pop. Okay? One term is push, another term is pop. How far you can push it means until the stack memory is filled, you can push it. How can you pop? How far you can pop means until this memory is removed out, you can pop. So there are 2 possible ways when you are using a stack, that is, one is pushing, another is popping. And the arrangement of the data inside the memory is in the form of first in last out. First in last out or last in first out. Both are same. That means whatever you are pushing first, it will come last, and whatever you are pushing last, we can pop it first. That's why it's called as first in, last out, and last in, first out. Let's take an example. A, B, C. A, B, C. First we pushed A, second we pushed B, third we pushed C. When it comes to pop, first we can pop C, then we can pop B, then we can pop A. So here first in, what is first in? Here first in is A. A is first in. Here last out is A. Here last out is A. Here first in is A. That means A we pushed first, but A we popped it last. So this diagram represents that first A is added, then B and C, while removing C is removed, then B and then A. That's why this concept is called as first in and last out, or last in, first out. Next, the CPU, the computer which use stack based CPU, the computer which use stack based CPU and based on the data structure called stack, based on the data structure called stack. So the organization which is related to the CPU organization, if it is the method is the stack based CPU organization, then that particular data structure is called as the stack. The stack is a list of data words. It uses last in, first out, the same thing, first in, last out, or last in, first out access method, which is the most popular access in most of the CPU. So it is the most popular access regarding it. So there is another term known as the stack pointer. Remember, stack pointer. See, what is the use of cursor? This which I am moving is called as the cursor. What is the use of cursor? Cursor will tell us where we are on the computer screen. In the same, this is a mouse pointer. Okay, this is a mouse pointer. This mouse pointer tells where we are on the computer screen, and in DOS we will find the cursor. Cursor will show you where we are on the computer screen. So in the same way, the stack pointer is the next term where it will show where you are in the stack. That means pointer will say that where you are there. So a register is used to store the address of the topmost element of the stack, which is known as the stack pointer. So the topmost element will be the stored, a copy will be stored in the one register, that means one memory location, which is separate from the memory location, and by seeing that, that is called as stack pointer. By seeing that, we can say that which is the topmost element in a particular stack. So in this organization, ALU operations are performed on stack data. It means both the operands are always required on the stack. So both operands are totally required on the stack. After multiplication, the results is placed in the stack. After doing all the different multiplications, the final result will be placed in the stack. So the two operations that are performed on the operations of the stack are push and pop. Push and pop are the both concepts which are performed on the stack. These two operations are performed from one end only. We are going to perform this at one end. Then comes the push. What is push? The operation results inserting one operand to the top of the stack. It decreases the stack pointer register. It inserts the data word at the specified address to the top of the stack. So it is going to store in the register based on the stack pointer, and the top of the stack will be identified, and on the top of the stack, by using push, we can going to insert another element, and that will be noted in the stock register, whereas it even decreases the stock pointer register. So one after one we are going to insert. That procedure is called as the push. So actually already I said this is push. This is the empty stack which you are seeing, nothing is there. We are pushing 1, okay, next we are pushing 2, here we are popping 2. Popping means taking out, pushing means keeping insertion, keeping inside the empty stack or memory stack, okay. Then comes to the pop. This operation results in deleting one operand from the stack, from the top of the stack, and it increases the stack pointer register. It will increase the stack pointer register. It even deletes the data word to the stack of the specified register. This is all about the push and pop. Next comes to the advantages and disadvantages of stack based CPU organization. Efficient computation of complex arithmetic expressions. Execution of the instructions is fast because operand data are stored in consecutive memory location. Different memory locations, the operands are stored. That's why the execution of instruction is fast. Then length of the instruction is short as they do not have address field. Since here we are not going to have any address field, the length of the instruction will be very short. So these are the three are the advantages. That means it can do very complex arithmetic calculations efficiently. Second one is execution of the instructions is very fast because of data is stored in different memory, consecutive memory locations, and the operand of data is used, so it will be executed very fast. Third one is the length of the instruction is short because there is no any address field. So consecutive memory locations, beside memory locations only the data will be stored. Since no need to search for the data in different address fields, here the length instruction is short as they do not have address field. Here there is no address field. Then the major disadvantage is size of the program increases. It will have a big size of the program. That is the major disadvantage regarding the stacks. Next comes to the queues. After the stacks, the next concept is the queue. Okay, stacks, we taken an example that books, keeping books one by one, or keeping cup and saucer one after one, or plates one after one. These are the examples of stacks. What is the example for queue? Taking the tickets in the theater. You are going to take the tickets in the line. When you form a line, whoever goes front, that will be number 1, and he will get the ticket first. Who will in the end, that is number 5, he will ticket the last. After 1, 2, 3, 4, then only he will get the ticket, that is number 5. So here there will be a queue will be having a front end and rear end. At the front end only the activity will be taken place, and at the rear end no activity will be taken place. A queue is a linear data structure, which follow a particular order in which the operation is performed. So the operation should be performed. It will follow a particular order. Okay. The order is first in and first out. The order which is known as the first in and first out. A good example of queue is queue of a customers of resource will be the customers first will be served. So whatever it may be cinema theater or ticket reservation or airport counter or whatever counter it may be, the first come will be served first. So this is the concept FIFO, first in first out. First come will be served first. The difference between stack and queues is removing. So it's the stack will remove the item most recently added, whereas queue will remove the item least recently added. So the first, whoever comes first, that person will be served first. The queue concept is first come first out. That means first in first out. Next, the differentiate between the stack and queue. We are going to discuss regarding what is the difference between a stack and a queue. So let's see what is the main difference between the stack and the queue. Stack is based on the LIFO, means last in first out principles. That is, the element inserted at least in the first element to come out in the last. So whoever inserted the first element will come in the last. That is the concept of the stack. Whereas the concept of the queue is first in, first serve. That means whoever comes first, they will be served first. So first in, first serve. So it is quite opposite. Queues are last in, first out. Stacks are last in, first out. Queues are first in, first out. Next comes to the insertion and deletion procedures in stacks and queues. Insertion and deletion in stacks will place only from the one end, that is called as the top. Insertion and deletion will take place at only one end, that is called as the top. Whereas here the insertion and deletion in queue takes place from the opposite ends in the list. So it will take in the opposite end. That means from the rear end, you are going to see here. From the rear end you are going to insert. From this end you are going to insert. That is about the rear end. Insertion is from here and deletion is from here, the front end. So from rear end you are going to insert and from front end you are going to delete. That's the difference between the stacks and queue. Whereas in stacks you can see from the only one end you are going to insert and you are going to delete. Pop and push and pop will be from the one end in the stack, whereas in the queue there will be two ends, whereas insertion will be from the one end and deletion will be from the another end. Next comes the insertion operation is called as push operation, and here the insertion operation is called as NQ operation. So when we go to the in-depth concepts regarding the queues, you can understand, that is DQ, NQ, circular queue, all these will come in the data structures, not in the subjects. Here only to understand the stacks, how the memory allocations, how they are allocated, and what is the procedures which we are going to use in the CPU organization. To understand CPU organization concept, we are looking towards the stack and queues, not going in depth regarding the stack and queues. Next comes to the concept of stack and queue. Delete operation is called as the pop operation. Delete operation is called as the DQ operation. Here there are two different operations, that is delete operation is called as the pop operation. Next is the delete operation is called as the DQ operation. Next here is, in stacks we maintain only one pointer to access the list, that is called as the top of the list, top of the stack, which always points to the last element present in the list. The top of the list it will be stack and always it will be the last element which is presented. Next here in queues, in queues we maintain two pointers to access the list. The front pointer always points to the first element inserted in the list and is still present, and the rear pointer always points to the last inserted in the element. This is the major difference between the stack and the queue. And then the final concept regarding it is, stack is used to solve problems, works on recursion. So stack is used to solve the problems which is related to recursion, and whereas queue is solving the problem having sequential processing. It will give only the sequential process of solving problems. Next step is the subroutines. We are going to discuss regarding the subroutines. We discussed the stacks, we discussed queues, and now we are going to discuss regarding the subroutines. Here a subroutine is a set of instructions which are used in a program and can be used whenever we want repeatedly in the program. So ante functions ela untayo ikkadiki vachevāriki subroutines alage untayi. So how the functions are there in previously how you have the functions, in the same way here the subroutines will be there. A set of what is a subroutine? A set of instructions which are used repeatedly in a program. Okay, that means a set of instruction is nothing but a block of code which is used repeatedly in a program, and we can use that particular block wherever we want within the program. Then that is called as the subroutine. Only one copy of this instruction is stored in the memory. What is the use of subroutine? No need to replicate the code. only one copy of the code will be stored in the memory, and this can be repeated how many times we want. So when a subroutine is required, it is called, it can be called many times during the execution of a particular program. At the particular program, when you are executing a program, you can call so many number of times as per the requirement. A call subroutine instruction calls the subroutine, and care should be taken while returning a subroutine as a subroutine and called from the different places from the memory. So subroutine can be called from the by using the instruction calls, and it should be returned, and this is the major procedure in the subroutine. Next comes the concept of PC must be saved by call subroutine instruction to make correct return of the calling program. So here the major task is not only the creating a subroutine, you have to call the subroutine and you have to return the subroutine. That means instructions should be given correctly when you are calling the subroutine program. So these are all the steps, these are all the things which are involved regarding the subroutine. How it will work, the process or block diagram of the subroutine is on the screen. So instruction is the first step, then after the instruction the next step is the call subroutine instruction, which gives to the subroutine and it will go to the next instruction. This is a cyclic method, or this is a method how many times you want to repeat, the same thing we can be used. So subroutine linkage method is a way in which computer call and return the subroutine. The simplest way of subroutine linkage is saving the return address in the specific location. You are going to save the return address in a particular location. Such register can be called a link register called subroutine. So this is all about the subroutine. Next comes to nesting subroutine. See, loops, you are having nesting loops in C programming. In loops concept, you might have understood both the nesting loops. That means a loop within a particular loop is called as nesting loop. If a loop is there in a particular loop, then it is called as nesting loop. For example, multiplication table, you are going to use one particular loop, and whereas you will give a range of multiplication tables. That means print the tables from 5 to 10. Fifth table you have to print 6th, 7th, 8th, 9th, 10th. So what you are going to use? You are going to use a nested loop. A loop will be within the loop. Another example is for arrays. For arrays, all the arrays you are going to use nested loop. That means one loop will be for the rows and another loop will be for the columns. So that is the nested loop. Nesting means a loop within the another loop. So here in the same way, subroutine nesting. A subroutine calling another subroutine is called as the subroutine nesting. If a particular subroutine we are calling another subroutine, then it is called as the subroutine nesting. Subroutine nesting is a common programming practice in which one subroutine is called another subroutine. Subroutine 1 will be called to subroutine 2, subroutine 2 will be called to subroutine 3. So return address of subroutine 1 is the link register. So this is subroutine 1 will call to subroutine 2, subroutine 2 will call subroutine 3, like that it will go on. Next, assume that when subroutine 1 calls subroutine 2, the return address of subroutine 2 will be saved somewhere. So we are calling subroutine 1 and subroutine 2 will return the address to subroutine 2 and it will be saved somewhere. So if the link register stores the return address of the subroutine 1, this will be destroyed or overcome. So if we are going to link the register, it will be destroyed or it will be overwritten by return address of 2. That means if we are storing the address in one place and for the second subroutine it also should store in another some place, unexpectedly it can be destroy the address field which already stored, or it will be overwritten. On it again it can be written. So this problem will come. So to overcome such a problem, as a subroutine called is first one to be written, last one lost in the first out format. So you are going to use the stack here. So that is the main advantage of stack. Once you show, again I will explain you. See here, S1 subroutine 1 address is stored in this box. This is the memory. Okay, this is M1. Okay, this address will be stored. What is storing here? Address. This address will be, this address is stored in M1. Where it is stored? It's stored in M1. And this address also, if I store in the same memory location, what it will happen? It will overwrite. It will overwrite, or the data will be removed. So the memory is here. Subroutine 1 will store here and 2 also will store here, means it will lose the data. To overcome this problem, what we are using is, we are using stack. That means S1 will store in the stack, then S2 will store in the stack, S3 will store in the stack, like that. The memory data will be stored in the stack, so that the address will not be overwritten or destroyed. Is it clear? Next, the small pieces of code. The small pieces of code might be written again and again, many different parts of the program. So many different parts of the program, a small piece of code can be written again and again. So again and again we are going to write the small piece of code in the memory. To avoid it, the subroutine that is used commonly is code once and use number of times. That means write the command code only once and we can use it number of times. So redundancy will be reduced by using a subroutine. What is the advantage of subroutine? By using subroutine, we can overcome the problem of the redundancy. Redundancy can be overcome by using a subroutine concept. Next comes to the subroutines. What is a subroutine? A set of common instructions that can be used in a program many times. It is called as subroutine. Next comes to each time a subroutine is called in the main program, a branch is made to the beginning of the subroutine. The branch can be made for any part of the main program. This branch can be made for any part of the main program. So the first memory location to each subroutine serves as the link between the main program and the subroutine. It will provide a link between the main program and the subprogram. Then comes to the procedure for branching to a subroutine and returning to the main program is referred to as a subroutine linkage. The return and the branching of the main program is called as the subroutine linkage. Next comes to in a program, the subtasks that are repeated on a different data values are usually implemented as subroutines. So the subtasks which are used and which can be repeated number of times, that comes under the subroutines. By this we are completing today's session, that is about the stacks, queues and subroutines. So by this we completed the stacks, queues and subroutines. Hope you all understood well. In next class we are going to discuss some other topic. Thank you very much.